So now we'll develop some formulas for the derivatives so that we can compute them within ease. So recall the derivative of function f prime is limit as h goes to 0, f of x plus h minus f of x over h. Right? I mean, provided this limit exists. So first thing we want to prove is that derivative of a constant function is 0. So how would we go about it? We will basically, so in this case, f of x can be thought of as a constant function c for all x, right? So then the derivative is going to be f prime x is limit as h goes to 0, f of x plus h minus f of x over h, right? So this is your definition of derivative. In this case, we have limit as h goes to 0. Now, if a function is a constant function, no matter what your input is, the output is going to be constant, right? So we get here c minus c over h, and that is already limit as h goes to 0 of 0 over h. That is already 0. Okay, it's not 0 or 0 form. Then you get 0 over h, which is 0. So the limit is 0. So the derivative of a constant is 0. In other words, I can write d by dx of c is 0. Now we have already seen derivative of x is 1, x squared is 2x, and derivative of x cubed is 3x squared. So from here, we should be able to get the pattern that if n is any real number, then d by dx of x to the n is n times the power comes down. As you see, the power comes down and you reduce 1 from the power. Right? So this is a derivative in case of. Now you can see this when you can see the proof of this when you are when n is a natural number easily. If n is a natural number, the proof is rather easy. Why is it easy? If n is a natural number, then you have f prime x equals to limit as h goes to 0, f of x plus h minus f of x over h. This is going to be limit as h goes to 0, x plus h to the power n minus x to the power n over h. And then you can use a to the n minus b to the n formula. So a to the n minus b to the n is a minus b times a to the n minus 1 plus a to the n minus 2 times b plus a to the power n minus 3 times b square, so on. Keep on reducing the power of a and increasing the power of b until you get b minus 1. So this becomes a, so a minus b, which is going to be x plus h minus x. And then here you will have x plus h to the power n minus 1 plus x plus h to the power n minus 2 times x, and you keep on going until you get x to the n minus 1, the whole divided by h. So you can cancel cancel, sorry, x and x cancel, and h goes 1 times. And when you put h equals to 0, you will get x to the n minus 1. The second one is x to the n minus 2 times x, which is again x to the n minus 1. And there are n of these guys. So but this proof is only valid when n is a natural number. If n is not a natural number, this will not work. Okay. The second one is if you have c is a constant and f is a differentiable function, then derivative of c f of x is the c can come out d by dx of f of x. Now again, in this can be proved using uh, the definition as well. So you have what is derivative of d by dx of c f of x. That by definition is limit as h goes to 0 c f of x plus h, because your new function is now c f of x, right? C times f of x over h. C is common, you can take it out. You can actually bring it out of the limit as well because there's no h involved. It's a constant, x over h. And now this is going to be c times f prime x. So constant multiplication rule is also valid. And I can write this if I want. This is already good enough as an answer, but if you want, I can write it as c times derivative of x. Now, if you combine this together, you can now, okay, so now we can talk about the sum rule. Similarly, you can prove for sum rule as well that derivative of f plus g is derivative of f plus derivative of g. Again, by the definition of derivative, all right? So let me quickly, so the left-hand side is limit as h goes to 0. Now instead of f, you have f of x plus h plus g of x plus h. This is your f of x plus h, right? This is a new function minus f of x plus g of x divided by h. Now you break it, you combine this two together, this guy and this guy, and then you combine the other two, this one and this one. So you will get, and then after rearranging a little bit, you can see that this is limit as h goes to 0, f of x plus h minus f of x over h plus g of x plus h minus g of x over h. Now, if you take the limit, it's equal to the individual limits, and you get first one is f prime x the second one is g prime x. So the sum rule is also valid. Now, if you combine this sum rule and with the constant multiplication rule and the power rule, you can easily take out derivative of any polynomial now. So what is p prime x? So p prime x is going to be d by dx of a n x to the power n minus 1, a n minus 1 x to the power n minus 2 dot 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 a1 plus a0. Now you can basically distribute because of the sum rule. So you have, and then take out the constant. So d by dx of x to the n plus a n minus 1 d by dx of x to the n minus 1 dot 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 plus a1 times d by dx of x plus d by dx of a0. So now when you write down, this is going to be an times n into x to the power n minus 1 plus an minus 1 times n minus 1 times x to the power n minus 2 all the way until a1 times 1, and derivative of this is 0. So this is the general form of the derivative. Okay. So now let's go ahead and compute the following derivative. So find equation of the tangent line to the curve 2x cubed minus 7x squared plus 3x plus 4 at point 1, 2. So the point is already given to us. We need to find out slope. So slope is dy by dx at x equals to what? 1. Right? So first compute dy by dx. So this is the slope. So first dy by dx. So dy by dx at x equals to 1 is your slope, is your f prime 1, right? Or m, whatever you want to call it. So let's compute first f prime of x, or dy by dx. So dy by dx, now we can directly combine the sum rule and the power rule and the constant multiplication rule. So we get 6x, so 2 times derivative. Let me just do the first one. So 2 times 3x squared minus 7 times 2x plus 3. So therefore, m, which is dy by dx at x equals to 1. So I'll substitute instead of x, I'll put 1 now. So I get 6 minus 14 plus 3. So that is going to be 9 minus 14. So 9 minus 14 is what? Minus 5. So therefore the equation of line is y minus 2 equals to minus 5 times x minus 1. So this is your equation of line. Okay. Now f of x equals to a to the power x, where a is greater than 0. And if a is not 1, then we call such a function as an exponential function. And now what is f prime of 0? F prime of 0 is limit as h goes to 0, a to the power h minus 1 over h, right? Why? Because f prime of 0 is f of limit as h goes to 0, f of 0 plus h minus f of 0 over h, that is limit as h goes to 0. F of 0 plus h is f of h. F of h is a to the power h. F of 0 is a to the power 0, which is 1, whole divided by h. And this says, the fact says that this limit exists. What it is, we'll see later, but for now, we can say that it exists, all right, without proof. So then it's easy to see what is f prime of x. F prime of x is limit as h goes to 0, f of x plus h minus f of x over h. So this is going to be limit as h goes to 0, a to the power x plus h minus a to the x over. Now using the laws of exponent, we can simplify it. So we get a to the x times a to the h minus a to the x over h. Now you can pull out a to the x common. So you get limit as h goes to 0, a to the x common in bracket a to the h minus 1 over h. Now a to the x has no h in it, so it can come out limit as h goes to 0 of f, or sorry, of what? F of a to the, of a to the h minus 1 over h. And now as it goes to 0, this limit is same as f prime of 0. What it is, we don't know yet, but we'll know it soon. Actually, later on, you'll see that f prime of 0 is actually ln of a. Okay, but for now, we don't know it, so I'm just keeping it hidden here. Okay. Now, this is something we must know, that limit as h goes to 0 of e to the h minus 1 over h is 1. All right. So you can try to look at some values and see that this is indeed true. So if I take h equals to 0.1, I do e to the x, e to the h minus 1 over h, I get 1.051. Now let me take some smaller values of h. That means putting some zeros. So you see, it is getting closer and closer to 1. Let me take few more. So this is now getting close to, so I'm taking h to be really, really small number, getting close to 0. So you see the zeros are moving. So now let me take some more. So now this is close to 0, and you see that your limit is also close to 1. It doesn't matter whether you take the positive side or negative side, the limit is still going to be close to what? 1. So that's the idea. So this limit is 1. So now what is the upshot of that discussion? The upshot of that discussion is, if instead of a, I have e to the x, so what does it mean? If you look at the other one, so if you have that, we have f prime, if f of x is equal to e to the x, then f prime x is going to be what? Is going to be f of x times f prime of 0. And what is f prime of 0? We already have seen that f prime of 0 is 1, right? So therefore, f prime x equals to f of x. So this means derivative of e to the x is e to the x, all right? Any comments so far? Okay, so let's move ahead. Now let's differentiate this function. So we have f of x equals to 2 to the power x cubed plus 3x to the power 2 by 3 minus e to the power x plus 2. So what is f prime of x? So now we can use the power rule. This may look slightly different. So what we'll do is we can break it as e to the power x times e squared. Now e squared is a constant, right? Because e is some 2.71 something. It's approximated by that number. Of course, it's an irrational number. So I cannot write down all the digits of it, right? Because because irrational numbers have non-recurring, means, and non-terminating decimal expansion. That means what? The decimal expansions will never stop, and there's no pattern in their expansion. Yeah, that's why you remember. Have you seen the movie Life of Pi? There is a competition where somebody remembers 500 digits of pi. So people are working like there. Recently on Pi Day, there was somebody from Google who basically announced some really large number of digits of pi. Yeah, because but nobody has a competition about give me all the digits of 1 by 3 or 500 digits of 1 by 3, right? Because we know the digits of 1 by 3 have a pattern in them because it's a rational number. It's 0.33333333. But for pi or irrational number, that's not the case. So do not confuse. E is not 2.718, all right? Because 2.718 is a rational number, right? But it is approximated by that value. That's what I'm saying. All right, so if I write it like that, I get f of x equals to f of x equals to 2x cubed plus 3x to the power 2 by 3 minus this. Now use, for the first one we'll use the sum rule, constant multiplication rule, and power rule, and derivative of exponential function. So we get what? 2 times derivative of x cubed is 3x squared plus 3 times, again applying power rule on x to the power 2 by 3, that's going to be 2 by 3 times x to the power 2 by 3 minus 1. And e square will come out as a constant, and derivative of e to the x is e to the x. So we get 6x squared. This 3 and this 3 will cancel. So we have 2x to the power minus 1 over 3 minus e squared times e to the x. So this is the derivative of this function. Okay. Now let's ask the following question. At what point on the curve y equals to e to the x is the tangent line parallel to line y equals to x? So the idea is you have y equals to e to the x. So y equals to e to the x looks like that. Yeah, it grows like it's an exponential function. And you have tangent lines at every point. And now you're asking y equals to 2 to the x. So y equals to 2 to the x looks like more like. This is how roughly y equals to 2 to the x will look like. Let me draw it with a different color pen. And then you're asking at what point on the graph is the tangent line parallel to this? So then we are seeing what point will the graph be. So you have like that, and what point is the graph going to be parallel to this? So that's what we are asking. So let's use Desmos to see that. So let's do that. So Desmos graph. So here, so let me draw y equals to e to the x. So e to the power x. And let me draw y equals to 2x. So we are asking at what point these two lines are gonna be what? So at every point we have a tangent line here, right? We are asking at what tangent line to this graph will be parallel to this line. So it basically amounts, of course, my graph is incorrect because the scaling is not proper. So let me erase this graph then. So we need dy by dx. At what point is this equal to? Parallel means same slope, so it's equal to 2. But dy by dx is same as e to the x. So e to the x is 2. That is when x equals to ln 2. So when x equals to ln 2, you will see that y equals to e to the x is parallel. Okay, so actually, I will demonstrate that on the graph as well. Let's draw the equation of this line, right? So what is e to the power ln 2? E to the power ln 2 is e to the power ln 2 is 2. So the point is x coordinate is ln 2, y coordinate is 2. So therefore equation of line is y minus 2 equals to 2 times x minus ln 2. Yeah, why are we doing this? Because so that we can see on Desmos really that this is the case. So let's go back to Desmos and sketch the graph of this function, or sorry, sketch the graph of the tangent line and see if they are equal. So what did I get? I got y minus 2 equals to 2 times x minus ln of 2. So you see, at this point, this green line and the blue line are parallel to each other, right? See, they are parallel to each other, right? They are not. So that's the idea. Okay. So